Problem 35. If y equals negative 3x plus 24, what is the maximum value of the product xy? So these type of problems are very, very fun, very, very cool what happens here. So basically, here's the idea. This is optimization. Well, yeah, I'd probably call it optimization, not so much related rates, because we're going to just pull them all into one. So the first thing, okay, I want to get it in terms of one variable. Okay, we're trying to optimize this function, so our objective function is what we're going to call it. We're trying to optimize this function x times y. That's two variables. That's one too many. That's gonna be a multivariable thing, and we don't know. I could just say make this one infinity and that one 1. There's a problem with that, and we'll get to that. Okay? So that's the first thing. Once I get it in terms of one variable, the second step, so I'm leaving some space here to do that. The second thing I'm going to do is use critical points to find the max. And we can do that with the calculator as well, but we won't even need to go to the calculator. And here's to find the max. Okay? So let's do just that. And remember, this critical points is we'll find them either where f prime of x, or not f prime in this case, because we aren't dealing with a function f, but where our objective function, and we are going to solve it in terms of x, so I'll put x right here, equals 0, or O prime of x is undefined. Okay, so we're looking back up here, and the first step, get in terms of one variable. O of xy equals x times y. Well, this is really easy to get in terms of one variable because I know that y equals negative 3x plus 24. So I know that this is equal to O in terms of one variable is equal to x times negative 3x plus 24. Which, for purposes of taking our derivative down here, it'll be a little bit easier to see this as negative 3x squared plus 24x. Okay. Now we go down here, and we're trying to take the derivative, find where it's undefined. Well, this is a polynomial. The derivative will be defined everywhere. It's infinitely differentiable. It just gets a bunch of zeros once you take enough derivatives. So we're going to find where O prime is, where the objective function, the derivative of that is equal to 0. So first thing, the objective function of x, the derivative of that will equal, I bring the 2 out to the front, I get a negative 6x, and plus 24x to the first derivative of that is going to be plus 24. Okay, and I'm looking for where this is equal to 0, so we will let 0 equal negative 6x plus 24. Subtract a little 24, so we get negative 24 equals negative 6x. Divide by negative 6, 4 equals x. Hey, not my answer yet. Okay, so that's the x value that maximizes it. But we actually want the maximum value. And that means that I actually need to find what value this attains when x is 4. But that's really, really quite easy because I have this objective function. I have x equals 4, so let's evaluate then my objective function of 4 will be negative 3 times 4 squared plus 24 times 4. 4 squared is 16 minus 3. It's going to be negative 48. You do have calculators. If you can't do that in your head, you should be able to. But 24 times 4, that's going to give me 96. And that's going to give me 48. Now that is my answer. Before I circle it, it's worth noting, how did I know I had a maximum? And how did I know I had the maximum? And not a minimum or just a local maximum. And here's how I knew, is I looked at, let me see, do I have another color? I'll just use white, that'll show up. I knew that my objective function was a parabola, an opening downward parabola. I knew that it took on this shape. I knew that this derivative was 0 here at 4. And I also knew, since it was opening downward, that was a maximum, and it was the absolute maximum. I could go through other arguments about the derivative going from positive, so we have O prime of x is greater than 0 on this side, less than 0 on that side. I can go through all those arguments, but in the end, equals 48, maximum value, final answer.